Today we're going to be talking about graphing absolute value and piecewise functions. First, we're going to talk about absolute value functions. For this, you're going to need a calculator. Now, to graph an absolute value function, we're first going to graph the function on our calculator. Then we're going to find the point of the v, because remember, absolute value functions look like the letter V. They often look like this. And we're going to press Control T to see the table, and then we're going to plot the points. You need to make sure to include at least one point on either side of your V, otherwise your absolute value function will just look like a line. So let's go ahead and get started. First, take your calculator. Okay, if you start at the home screen here, you can either press this calculator button to go to graph, or you can go to graph right there. If you remember, this button toggles back and forth, so make sure you're on the graph page. Hit Tab. If you have stuff written up there, if you have graphs on there, remember you can always say Menu, Actions, and then delete all. Whoops, that said text. Menu, Actions, delete all. Number 4, yes. And that clears everything out. So we're good now. I'm going to type in this function into my calculator, the absolute value of x minus 5. To get the absolute value, right down here, there's this little book. Don't hit the book. Go next to the book. That's where the absolute value is. So hit that button and this menu pops up. Absolute value is right below the little fraction one. So we're going to hit absolute value. And then we're going to say the absolute value of x. Remember, x is way down here. And then I'm going to hit over to get out of the absolute value, and then I'm going to say minus 5. Mine has a capital X. Yours probably has a lowercase x. Doesn't matter. It just means caps lock must be on mine right up here. Now it'll be off. Okay, so enter. So there's my absolute value graph. It looks like the letter V. Now what I'm going to do to graph this on my paper is I'm going to look at the table so I can plot the right points, because it's kind of hard to just get the points. You don't just want to copy it down all haphazardly. We got to be accurate. So I'm going to say Control T, and I'm going to look at my table. Now, the place on the table that I need is the place where I'm at the points of the V, because I need to get at least one point on either side of the V. So this V I know is happening when x is 0. So right now I have x is 4, 3, 2, 1. I'm going to go up to 0 and then past it. And I know that I'm at least 1 point on either side of my V, because I can see the direction change in the y's. Like it goes from -4 down to -5 and then back up to -4. So whenever you find that direction change in the y's like that, that's what you need to include in your table, because you have to have at least 1 point on either side of the V. So I'm going to make this table. So I'm going to have -1, 0, 1, 2, -4, -5, -4, -3. And then I'm going to plot them. So -1, -4, 0, -5, 1, -4, 2, -3. Those are my points. I just plotted. Remember, each of these are an XY ordered pair. So like -1, -4, that's an ordered pair. So I go -1, down 4, -4. And then I just make my V. That's my graph. Come over here to this one. I'm going to do Control T to get back out of the table. Tab to get back up. I'm not going to make a new one. I'm going to go back up to the one I already made. And I'm just going to edit this. So instead of -5, it's +4. And then on the inside, instead of just an x, it says x plus 2. Okay? So now, I'm going to hit Control T. And I need to find that direction change in my y's. So right now, they're all going 7, 8, 9, 10. They're all going up. 6, 5, 4, 5. So there's my direction change. So I go 5, down to 4, back up to 5, and then 6. So I'm going to make my table here. And it says -3, -2, -1, 0. Those are the x coordinates. And then 5, 4, 5, 6. Those are the y's. So I'm just going to plot each of those ordered pairs. So my first ordered pair is -3, 5. So I go back 3, up 5, put a dot. -2, 4, -1, 5, 0, 6. And then I make my V. Okay? And now, here's my last one. So I'm going to Control T to get back out of my table, Tab to get back up there, back up to the previous graph. I'm going to delete the +4 because this graph doesn't have anything after the absolute value. I'm going to hit over to go inside. I'm going to delete the +2 because there's nothing in there with the x. And then before it, there's a -2. And that's negative as in this negative right here, not the minus sign. Enter. All right, so my ordered pairs that I'm going to graph need to look for that direction change. Just found it. So -2, up to 0, back down to -2, -4. So -1, -2, 0, 0, 1, -2, 2, -4. So that's this graph. And as we graph more of these, we can begin to notice some patterns. For example, anything outside being added or subtracted is going to move it up and down. This moved it down 5, moved it up 4. Anything inside is going to move it left and right. +2 moved it left 2. A -2 would move it right 2. And anything out here is going to make it skinnier or wider. And this negative flipped it upside down. So as we graph more of these, we can start to see some patterns. Now the next part of learning target 4 is piecewise functions. We don't need a calculator anymore, so you can set that aside. But we are going to need a pencil because we're going to have to erase. So if you don't have a pencil, pause this video right now and make sure that you and whoever you're watching this video with, if you're watching it with somebody, have pencils. So here's a pencil. When you're faced with a piecewise function, what we're going to do is we have to consider the domain of each individual function. So that is what you see out here after the comma. So we're going to draw each entire function with a pencil, and then we're going to erase the part that is not included in the domain of each function. So let's try this. So our first function is 2x plus 1. So that means if we think of slope-intercept form, this is my y-intercept here to +1. My slope is 2 over 1. So I'm going to go from this point, I go up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. And then I can go the other way, down to left 1 to get the other half of my graph. So it looks like this. Now, this graph, though, says it only applies for all the x's that are less than 2. So here's 2. This is like my borderline right now. This graph only is for all the x's that are less than 2. So I'm going to erase all of these. And I'm going to put an open circle right there because it's not equal to 2. It's just less than 2. So here's my first graph. Now I'm going to graph this other one, 4x minus 3. So I start at -3, and then up 4 over 1, up 4 over 1, up 4 over 1. So here is this graph. Now this graph is for all the x's that are greater than or equal to 2. So here's 2. This graph only applies bigger than 2, after 2. So it only applies from 2 on. Everything from before 2 doesn't. So I'm going to erase this graph before 2, like that. And then color that circle in because now it is with this function. And that is our function. Before 2, it's the first one. 2 and on, it's the f. It's the second one here. And that's how you make a piecewise function. Piecewise functions are really helpful in the world because A lot of times things change. Interest rates change, rates of speed, rates of filling things. Things aren't always constant. Sometimes they change part way. And so piecewise functions are actually really common and really helpful in the world.